Okay, pre-calculus students, well, we're ready to get back to learning some new stuff after spending quite a bit of time there reviewing chapters 6 and 7 and having that test. It was sure good to see everybody, even if it was just over a computer screen. I hope that you guys did okay. I will do my best to get those tests graded in a reasonably timely fashion. It probably won't be until near the end of this week. Maybe even it'll take me the weekend. The bottom line is it's going to take me longer to grade them because I have to grade them digitally than it would be if I was grading them straightforward. So I have to figure out the best way to do that when I can't actually write on the test itself. So I may have to do like a separate sheet of paper for each student. I just have to figure out how that's going to work. But it may take me just a little bit of time to do that. But I will hopefully get it done in a reasonably timely fashion and then let you guys know how you did. But we're ready to start chapter 8. So chapter 8 is all about conic sections. And when we're looking at these things, when we talk about conic sections, we're talking about sections of a cone. And a cone, actually, what we usually think of as a cone is actually half of a cone. The full cone has both a top and a bottom, and they meet in the middle with a point. I've got a great thing on my computer at school to illustrate these things to you, a conic section builder, which is a wonderful thing to look at. Unfortunately, I don't have any way to show that to you now, so we're stuck without that other than just look at the diagrams in your book is the best thing that I can do, I can tell you. So what happens is when we take this cone, which is a three-dimensional figure, and we slice it with a plane, the intersection of the cone with the plane forms different curves, different two-dimensional shapes. And depending upon how we cut the cone, it changes the shape. The shapes can be anything from a circle or something that is like a circle but not exactly uniform radius, that's an ellipse, to being either a parabola or a hyperbola. And what we're going to look at today we're going to start looking at the parabolas. And it'll take us actually 3 days to look at parabolas. So we're going to start here with them today. So this is 8.1, and we're going to start in here with parabolas. So let's go ahead, let's get started. So what is a parabola? Well, a parabola is a unique shape that's defined mathematically. And there's a couple things that we can look at. We can define it based on its equation. We can define it based on its physical characteristics. So here's what we're going to do. Our first thing is we're going to define it based on its physical characteristics. And we are going to say it's the set of all points that are equidistant. That means they're the same distance from a particular line. That particular line is called the directrix, and a particular point called the focus. So if we want to take a look at the points that are the same distance away from the line, and by the way, it is measured perpendicularly from that line, to the focus, if we look at the collection of all those points, we get a parabola. We get that shape of a parabola. And we're used to seeing that. We know our most common type we're used to looking at is y equals x squared. So here is a picture of what's going on. And so you may want to pause this and write. I would suggest pausing now and writing down the picture and then starting back up, and then I'll explain all these things. So pause the video, copy it down. I'll assume now that you've already got it copied down, I'm going to start explaining. So here's our shape that we look at as being our parabola here. And so what we see is that there's a point inside the curve of the parabola which we call the focus. And notice, by definition, if we take the distance and then this line right along here, that is our directrix. So this line is our directrix. If we want to kind of think of it, and I can show it kind of like that. There's our directrix as it goes along there. And so if we look at the distance from the focus to the directrix, and we take it where there's equal distance from here to here, that's a point on the parabola. So for instance, if I start on this point of directrix and I go perpendicular to the directrix, and I go from the focus and I go to the point that is equidistant, when I get to that point, that is on the parabola. So you see each one of these points, if I measure the distance from this point on the parabola to the focus and then perpendicular to the directrix, that would be the same distance. So you can see I've indicated those distances are all the same, and together the collection of those points form our parabola. Points were so this is called our focus, this is called our vertex, this is our directrix, and then the line that goes through the vertex right up through divides the parabola in half is the axis. Couple important things. This distance from the focus to the vertex we label as P, and we call that the focal length. This distance that we call the absolute value of 4P is what we call the focal width. It is actually the width of the parabola at the focus. We use absolute value because the focal length could be positive or negative. If it's positive, the focus is above the vertex and it opens up. If it's negative, the focus would be below the vertex and it would open down. But the focal width is just a width that's always positive. And so then there's our directrix. So now let's look at the basic characteristics here. And we're going to give you a chart. So these are the basic characteristics of a parabola with a vertex at HK. Now, you're used to thinking of a quadratic equation which produces a parabola, that ax squared plus bx plus c. You know that the graph of that ends up being a parabola. But one thing it is not a good form of, it is not a good form for giving us the vertex, which is the key point in the parabola. So we want to look at an alternative form for giving a parabola that is much better for describing the vertex and its focal width and its focal length and all of those key aspects. So with that, we're going to look at the characteristics of our parabolas. We're going to look at whether or not they open up and down, whether they're a vertically opening one, or whether they open left or right. So, the first characteristic is the equation. So, we have a description, we have a graph, but we need an equation. Well, if it opens up or down, the equation that we're going to use is this. X minus h squared equals 4p times y minus k. So this is for one, notice the x is squared, the y is not squared. That means we're opening up or down. They are functions. So our typical y equals x squared, that is of this form here where the x is squared, it's an up or down one. But this is our vertex form. It makes it very easy to pick out our focal length p and very easy to pick out our vertex, the values for h and k. And if it opens up left or right, it's very similar, except that now the y is squared. The k, which is the y coordinate of the vertex, still is paired with the y, and the h, the x coordinate of the vertex, is still paired with the x. But we just simply trade places with the x minus h and the y minus k when we go from vertical to horizontally opening. The next characteristic we're going to look at is the focus. So the focus is an important point to know. It's right here, particularly when you're looking at some of the unique applications of a parabola, which happens to be, for instance, that if you emit something from the focus, the parabola will bounce everything perpendicular straight out parallel to the axis, or if something comes in, it will be all bounced to the focus. So it's important to know where that focus is when we're doing things like that. Okay, so for the focus, notice if it opens up or down, the focus is merely P away from the vertex, but the x coordinate does not change. The left or right doesn't change, it just adds P to the y. So the focus, the h stays the same, the x coordinate of the vertex, and we simply add the P to the k, to the y coordinate of the vertex. And if it goes left or right, it's exactly the same, except we add the p to the h. So it's h plus p and then k. The next characteristic is the directrix. The directrix is this line here. And so notice what it is if it opens up or down, it is a horizontal line, which means it's of the form y equals some constant. And in this case, the constant that y is going to equal is going to be whatever the y-coordinate is of my vertex minus this p, because it goes in the opposite direction. And then for the horizontal, it will be a vertical line, so it will be x equals, and it will be the h minus p. Finally, the last thing that we have is the axis. Notice if it's opening up or down, the axis is a vertical line, goes through the vertex, so it's simply going to be x equals that x coordinate of the vertex h, and y equals k. So those are our basic characteristics here of the parabola. Well, now let's apply these things and see if we can answer some questions with it. So what kind of things are they going to ask you to do? So here on 5, I'm going to need to... So I had to pause there for a second and open up my book. So here on 5, they give us this equation for our parabola. 3x squared is equal to negative 4y. And so this is close to being in vertex form, but not quite, because notice in vertex form there is no constant here with the squared variable. So what I really need to do is divide both of these by 3 so that I would get x squared equals negative 4/3 y. Now this is in my vertex form. Notice there's no value added or subtracted from h, so h from x, so h is 0. Same thing for y. So this one is centered at the vertex at the origin. But what it asks us to do is find the vertex, find the focus, find the directrix, and the focal width. So the first thing we can see is that the vertex is going to be the origin, because there's nothing added or subtracted from x or y. The focus is going to be, I have to ask myself, is this vertical or is this horizontal? Well, since the x is squared, we know it's of the form where it's vertical. So my focal, my p here, this negative 4/3 is my 4p, like that. Negative 4/3 equals 4p. So if I go ahead and I divide by 4, I see that p is negative 1/3. So my focus, I must simply go negative 1/3 here, added to my k, which is 0. So my focus is 0 for h, same h is there, and I add negative 1/3 to 0 and get negative 1/3 there. The next thing it wants is my directrix. So my directrix, looking here, y, and I'm going to take my k, which is 0, minus p. So that's going to be k minus negative 1/3, or k plus 1/3. So it's going to be y equal to 1/3 for my directrix. And finally, my focal width is just the absolute value of this 4p there. So it's the absolute value of negative 4/3. So it is 4/3. All right, let's look at another one. Number 19. We have a vertex, we have a direction that it opens, and we have a focal width. And what it wants us to get here on 19 is it wants us to get this equation for this parabola. So the first thing I have to do is know which equation do I grab? The one for up or down? I'll slide this back down a little bit so you can see, do I grab the one for up or down, or do I grab the one for left or right? Well, it opens down, so I know immediately this is the equation that I grab. So I know immediately I'm going to grab this equation. So I have to fill in order to get my equation, h, k, and p. Well, h and k are very easy to fill in. They're from the vertex. They're both 0. So that's going to give me just x squared is equal to 4p times y. Just plugging in 0 for h and k. Now I just have to find p. Notice my focal width is 6. So this 4p has to be equal to 6. So solving that, I simply put that negative 6, I put 6 in for 4p, but since it opens down, the p has to be negative, so it's going to be negative 6 and times y. So I have x squared is equal to negative 6y. And that's my equation. All right, let's look at another one. So same type here. We're given a vertex of 4, 3. We're given a directrix of x equal to 6. And we're also told that's it. That's all we have. So what I need to do is, first off, I have to figure out, does this open up or does this open down? So in this case here, I know that my vertex is at 4, 3. My directrix is at since it's x equal to, that means it's going to be of the form for directrix. It's going to be of this form here. It's going to open up left or right. So my directrix is a vertical line. So it is going to open up either this way on my vertical line, or it's going to open up this way. So the key thing here is this x equal to 6 is to the right of this 4 where the vertex is. So that means that it must open up to the left. So what I'm going to have is, here's my horizontal equation. So it's going to be y minus the y coordinate of the vertex, that's my k, squared equals 4p times x minus my h coordinate there. Now all I have to do is find p. Well, I have my directrix, and I know that my directrix equation, if I look at directrix, in this case for left or right, I know that x is equal to h minus p. So in this case here, I know that it's going to look like this. I know that that is going to be my 4 minus p. I also know that my directrix is x equal to 6. So I know 6 has to be equal to 4 minus p. Solving for p, I see that in order to get p would have to be negative 2. So substituting in negative 2, I get y minus 3 squared equals negative 8 times x minus 4. And you could also do that one by inspection. You could say that since my directrix is negative 6 and my vertex is at 4, the x coordinate's 4, I have to go 2 to the right to get to the directrix. So to get to the focus, I would have to go 2 to the left. That would mean just negative 2. And so I could immediately put negative 2 in for p like that. That's the other way I could do it. Okay, here's your homework. So it's going to be 2, 4, and then 6 through 30 multiples of 3. And that's from 8.1 on parabolas. So I hope things go well. You can remember we have a Zoom conference for any questions and answer time, any tutoring help you need tomorrow at 12:30. So hope this finds you well, and we'll be making another video tomorrow.